Building on what we learned about installing essential tools, requirements, and libraries modules, today's session dives into the code that brings a chatbot to life. We'll explore line by line how this code interprets user input, identifies the intent behind it, and generates a relevant response. Buckle up because we are about to unlock the secrets of this intelligent conversation partner. Now, here's where it gets interesting. We need to define our chatbot's intents. These are like categories of conversations our bot can handle. Let's create a few. Each intent has a tag, some patterns the user might type, and possible responses from our bot. Feel free to add more intents to make your chatbot more versatile. Preparing the model. Now, let's get to the machine learning part. We'll use a TF-IDF vectorizer to convert our text data into numbers and a logistic regression classifier to predict the right intent. Step 1, initialize the TF-IDF vectorizer and logistic regression model. TF-IDF vectorizer converts a collection of raw text documents to a matrix of TF-IDF term frequency inverse document frequency features. This is a common technique in text mining to transform text into numerical features that can be used by machine learning algorithms. Logistic regression initializes a logistic regression model with a fixed random seed random underscore state 0 to ensure reproducibility and a maximum of 10,000 iterations to converge to a solution. Step 2, prepare data. Tags and patterns are lists to store the labels and the text data, respectively. Intents is assumed to be a list of dictionaries, where each dictionary contains a tag and associated patterns examples of text that should be classified under that tag. The nested loop iterates through each intent and its associated patterns, appending the tag to tags and the pattern to patterns. Step 3, train the model. Vectorizer.fit underscore transform patterns fits the TF-IDF vectorizer to the patterns and transforms the patterns into a TF-IDF matrix X. Y equal to tags sets the labels for the patterns. CLF.fit XY trains the logistic regression model using the TF-IDF features X and their corresponding labels Y. In summary, this code prepares the text data and labels, transforms the text data into numerical features using TF-IDF, and then trains a logistic regression model on these features. This trained model can then be used to classify new text inputs based on the learned patterns. This might look complex, but don't worry. We're just teaching our bot to recognize patterns and match them to intents. The chatbot function. Now, let's create the heart of our chatbot, the function that generates responses. This function takes the user's input, predicts the intent, and returns a random response from that intent. Simple but effective. Step 1, define the chatbot function. This defines a function named chatbot, which accepts a single argument input underscore text. Step 2, transform the input text vectorizer dot transform input underscore text transforms the input text into a TF-IDF feature vector using the already fitted TF-IDF assumed to be fitted with the training data in the previous step. The input text is wrapped in a list to match the expected input format for the transformer. Step 3, predict the tag TLF.predict input underscore text uses the trained logistic regression model to predict the tag for the input text. 0 extracts the predicted tag from the result, as predict returns a list of predictions. Step 4, find the corresponding intent and return a response. The function iterates through the intents list, which contains dictionaries of tags and responses. If intent tag equals to tag checks, if the current intents tag matches the predicted tag. Response random.choice intent responses selects a random response from the list of responses associated with the matched intent. Return response returns the selected response. Creating the user interface. Last but not least, let's create a user interface using Streamlit. This will allow us to interact with our chatbot through a web browser. Function, this defines a function named main which will serve as the entry point of the Streamlit application. Step 2, set the title and introduction. st.title chatbot sets the title of the web app to chatbot. st.write welcome to the chatbot. Please type a message and press enter to start the conversation. Displays an introductory message to the user. Step 3, capture user input. st.text underscore input you creates a text input box for the user to type their message. The label you indicates that the user should type their input here. The user's input is stored in the variable user underscore input. Step 4, generate and display the chatbot's response if user underscore input checks if the user has entered any text. Response chatbot user underscore input calls the chatbot function defined earlier with the user's input and stores the response. st.text underscore area chatbot value response height 100 max underscore chars none displays the chatbot's response in a text area. The label chatbot indicates that this is the response from the chatbot. The height and max underscore chars parameters control the display properties of the text area. Step 5, run the main function. This is a common Python idiom that checks if the script is being run directly as opposed to being imported as a module in another script. If the script is run directly, the main function is called starting the Streamlit app. In summary, the main function sets up a simple Streamlit web app for interacting with a chatbot. It displays a title and introductory message. It provides a text input box for the user to enter their message. When the user submits a message, it calls the chatbot function to generate a response. It then displays the chatbot's response in a text area. The script runs the main function if it is executed directly, starting the web app. And there you have it. We've just created an end-to-end chatbot with a web interface. Running the chatbot. To run your chatbot, save your Python file and then open your terminal. Navigate to the directory containing your file and run. Enter the command streamlit run chatbot.py. And that's it. Your chatbot is up and running. Try typing some messages and see how it responds. That's all for today, folks. We've built an end-to-end chatbot from scratch using Python. Remember, this is just the beginning. You can expand on this by adding more intents, improving the ML model, or enhancing the user interface. If you enjoyed this tutorial, don't forget to like and subscribe for more coding adventures. Until next time, happy coding.